Hello everyone, my name is CHEN-YU. Today I will teach the derivative rules. Although we can calculate derivative using the limit process, there are many rules that can simplify and speed up this process. These rules are especially useful for polynomial functions. They have some very easy to remember rules that let us avoid doing teacher's limit calculations. For example, for polynomial function, we can use these rules to quickly find its derivative without solving the limited process step by step. This not only make the calculations faster but also reduce the chance of making mistake. In addition to this, there are other types of functions, such as those involving reciprocals or those involving radicals, which can also be differentiated using similar techniques. The application of these rules is broad and is not limited to a polynomial function but covers a much wider range of mathematical function types. By mastering and applying these rules, we can handle various complex derivative problems more flexible, thereby achieving higher efficiency and actually in mathematical analysis. So let's look at this slide. The first rule we see here is called the constant rule. It says that if f of x equal to c, where c is constant, then f prime of x equals 0. To break it down, if f of x equals to c, where c is a constant, then f prime of x equals to 0. Similarly, if y equals to c, where c is some real constant, then by dy over dx equals to 0. Geometry. This means that the function f of x equals c is a horizontal line with 0 slope. To understand this better, imagine a flat, horizontal line on a graph. Since the line is flat, there is no rise or fall, it completely level. Because of this, the slope of the line is 0. That's why the derivative which measures the slope is 0. More formally, we can obtain the same result using the limit definition of the derivative. But the key takeaway here is that the derivative of any constant function is always 0. So to summarize, if we have a constant function, its derivative is 0. This is because a horizontal line has no slope. It's perfectly flat. So now let's look at this. The formula for the derivative using limit is shown here as f prime of x equals the limit as h approach 0 of the fraction f of x plus h minus f of x over h. So since the function is horizontal line, f of x plus h equals f of x for any value of h. This is because adding h to x doesn't change the value of a constant function. So the formula becomes f prime of x equals the limit as h approach 0 of the fraction f of x minus f of x over h, which simplifies to f prime of x equals the limit as h approach 0 of the fraction 0 over h, which equals 0. So since f of x minus f of x is always 0, no matter how small h is, the numerator remains 0. Therefore, the result of limit is 0. Additionally, the note at the bottom reminds us that in the limit h approaching 0 does not mean that h equals 0, but in this case, the result is indeed 0. So let's look at this example in this slide. We have two functions here. The first one is f of x equals x to the power of 10. And the second one is g of t equals 1 over t to the power of 5. So first, let's find the derivative of f of x. We use the power rule for derivative, which is f prime of x equals n times t to the power of n minus 1, where n is exponent. For f of x equals x to the power of 10, f prime of x equals 10 times x to the power of 10 minus 1, which is 10 times x to the power of 9. So the derivative of f of x is 10 times x to the power of 9. Next, let's find the derivative of g of t. We can rewrite g of t as t to the power of -5. And then use the power rule for derivative, which is g prime of t equals n times t to the power of n minus 1. Then, for g of t equals to the power of -5, g prime of t equals -5, 5 times t to the power of -5 minus 1, which is -5 times t to the power of -6. Or we can also write it as g prime of t equals -5 over t to the power of 6. So the derivative of g of t can be written as -5 times t to the power of -6 or -5 over t to the power of 6. So let's look this slide. The constant multiple rules say that if f of x equals k times g of x for some real value k, then f prime of k equals k times g prime of x. To break it down, if f of x equals k times g of x for some real value k, then f prime of k equals k times g prime of x. Similarly, if y equals k times u for some real value k, then dy over dx equals k times du over dx. Now, let's see why this is true using the limit definition of a derivative. We start with the limit definition. F prime of x equals the limit as h approaches 0 of the fraction k times g of x plus h minus k times g of x over h. So we can factor out the constant k from the numerator. F prime of x equals the limit as h approaches 0 of k times the function g of x plus h minus g of x over h. Since k is a constant, we can take it out of the limit. F prime of x equals k times the limit as h approaches 0 of the fraction g of x plus h minus g of x over h. So by the definition of the derivative, the limit expression is just g prime of x. So f prime of x equals k times g prime of x. To summarize, the derivation of a constant times a function is the constant times the derivative of the function. We use the limit definition to show the step-by-step. So let's start with the sum and difference rules. These rules help us define the sum of difference of two functions. So let's see, if p of x and q of x are both differentiable and f of x is equal to p of x plus or minus q of x, then the derivative of f of x is equal to the derivative of p of x plus or minus the derivative of q of x. In mathematical notation, it looks like the derivative of f of x equal to the limit as h approaches 0 of the expression p of x plus h plus or minus q of x plus h minus p of x plus or minus q of x all divided by h. We can split this into two parts. The limit as h approaches 0 of the expression p of x plus h minus p of x all divided by h plus or minus the limit as h approaches 0 of the expression q of x plus h minus q of x all divided by h. The simplifies to the derivative of p of x plus or minus the derivative of q of x. So to put it in simply, if y is equal to u plus or minus v, then the derivation of y with respect to x is the derivative of u with respect to x plus or minus the derivative of v with respect to x. So this is show that we can find the derivative of a sum or difference of function by differentiating each function separately and then adding or subtracting their derivative. So the derivative rules I will just teach to here, then other you can go to our website to do the exercise and the assignment. Yeah, that's all. Bye bye.